Hey Ryan, how are you today?
Good, how are you?
Fine. Thanks for letting me move this back to 5 o'clock. I hope this works out.
Yeah, it should be fine.
Okay, you want to go ahead and paste the link into the chat window?
Yeah, it's right there.
All right. Where'd we get through?
32, I believe.
Okay. 33. Let's see. This isn't quite big enough. Let me blow this up a little bit. I need
All right, give
my...
me 1 minute. I gotta go grab my calculator real quick.
Okay.
All right.
Boy, this... I wonder why only happens with you. Wow, hold on. I got to close this out and reopen it. Okay. That, and I got that. Let's make this a little narrower. All right, can you read that?
Yeah.
Because I can make it a little bigger if you need me to.
Yeah, I think I can read. Yeah, that'll be fine.
Okay, use formulas to find the lateral area and the total surface area of the given prism. What makes this a prism?
It's three-dimensional.
No, prism has a very definite definition.
Sure.
It means that it has two equal and opposite and parallel faces. This triangular face here and this triangular face back there. And that's the
Okay.
only thing that makes this a prism. If those weren't parallel to one another and equal to one another, wouldn't be a prism. However, that's not really what we need to look at here. We need to look at surface area. The lateral area they're talking about, I believe, is the part between the bases. In other words, if you think of these triangles as the bases of the prism, then what's in between them is the lateral area.
Okay.
So
Now, this
let's,
is one we didn't get down on the note card. What is the surface area of a triangular prism?
well, you have to go through each face and count it up. In other words, there's no general formula. Whenever you have a object that doesn't have circular stuff in it, usually you don't have a regular formula. What we have to do here is let's first figure out the lateral surface area. In other words, let's ignore the area of these two end triangles since they want the lateral first. So we need the dimensions on each of these. How many faces make up the lateral surface area?
The lateral?
Uh-huh.
2. No, 3.
3. There's this slanted top face. There's the bottom base, which is 2, and there's this back face. So that's
Right.
3. So we need the dimensions of each of them. What's the dimensions of this top slanted face?
Top slanted, 38 by 9.
Well, gives me some problems because how can that be 9?
Isn't that what it's...
If we look at this front left triangle, this is 4 and that's 8 and that's a right triangle. So what is this hypotenuse? It's the square root of 16 plus 64. That's the square root of 80. That is not 9. Ah. Wow, I cannot believe they did this. Square root of 80 is very close to 9. But it's not 9. But I'll go with whatever dimensions they put on here. So I hate that they did this, despite the fact that they say, show your answer rounded to the nearest whole number. But they never should do that on a dimension. That isn't 9. That's the square root of 80. It's a little bit less than 9.
Right.
But okay, I'll go for the dimensions of this are 38 by 9. How about the dimensions of the bottom piece?
The bottom piece is 38 by 8.
Okay, and the back piece?
4 by 38.
Okay, so that's the sum of those three is the lateral surface area.
Right.
Let me see if I can do that math in my head. That's 21 times 3. No, it's 38 times 21. What is that? You have a
798.
Okay, so we got this lateral surface area. It's either A or C. And what's the total surface area? What do we have to add to that?
The lateral area?
No, we just calculated the lateral. That was the lateral.
Oh, okay.
In other words, remember the lateral area is the area between the two bases. It doesn't matter whether it's how it's oriented. Or this doesn't have to be standing vertically for that to be the lateral area. It can be laying flat on a table, and that would be the lateral area, because the lateral area is defined as between the two parallel bases that make it a prism.
All right.
So we need to add to that those two bases. What's the area of both bases?
Base times height here. 8 times 4 is 32, so that's 16, plus 9 times 4 is 36. So...
No, this 9 is that hypotenuse. In other words, this back triangle is the same as this front triangle.
Oh, so it would be 32. Okay.
Yes. Okay. So we just add 32 to 798, and we get 830. So it's got to be C. Find the surface area of the cylinder in terms of pi, which means find the surface area and don't convert, leave it in pi. That's all it means. So the surface area of the cylinder, now we have a formula for that. Well, not really. It's the area of the base times 2. So we'll say 2 capital B. Capital B, I'll go ahead and go with everybody else's notation here. Capital B is the area of one base. And what are we going to add to that?
Hold on.
The lateral area.
So it's 2 times the area of the base?
Right, we got two bases. Remember, surface area is just counting up all of the outside. So we got this circle here, we got the bottom circle, and then we got the part that's wrapped around the middle. So that's why it's 2 bases plus the lateral area. What's the area of each base?
Of each base, it would be, oh, that's pi r squared.
Okay.
So 36 pi.
Okay, we're going to leave it in terms of pi. Plus the lateral area. What's the lateral area going to be?
I don't remember.
Well, you always have trouble with this one. We got to figure out a way for you to memorize how to do this. Because we've done this probably 5 times. Think of a soup can with a label.
Okay.
When you unpeel the label of the soup can, what do you have?
Rectangle.
Okay? Always. We have a rectangle. What's the height of this rectangle?
36 pi.
No. That's the area of the circle. What's the height of this rectangle? We just peeled it off this soup can.
Oh, so 20?
Okay. What's the length? What's the dimension from there to there?
Would that be 36 pi?
No. It would be the circumference of that circle. Right?
Okay.
If you wrap a label around that soup can so that it just touches one another, in other words, it fits perfect with no overlap, then the length of the label after you unfold it into a rectangle is 2 pi r, the circumference of that circle. So 12 pi, because r is 6.
Right.
So there's your width and your length of this rectangle. What's the area of it?
20 times 12, so, yeah.
240 pi. So that's the lateral area we're going to substitute right there. 240 pi. So we have 72 pi plus 240 pi. Sounds like 312 pi to me.
Okay.
Okay? So let me do another one. Let's do a drill, because we don't want you to miss this problem. I'm going to give you another problem. Radius is 5. This is a beer can. Radius is 5. The height is 10. What's the total surface area?
Okay, so we got,
What's the general formula? Let's start with the general formula.
alright, 2 times the area of the base, plus the lateral area. And so we got 25 pi. So the base is 25 pi, yeah. And then we turn that into a rectangle where the height is 20.
10. 10.
Oh, sorry. Don't know why I thought that was 20. And then we got that rectangle. Then we do 5. So it's 10 pi on top. So 10 times 10 pi.
Okay.
And then we got 100 pi plus 50 pi.
Very good. Remember that exact methodology on all of the problems where you have to calculate the surface area, the lateral surface area of a cylinder.
Okay.
Because that's a very common problem, and you do every one of them in that exact way. Okay. Find the lateral area of the pyramid. Let's get the formula since they want just the lateral area. First of all, let's look at surface area. Surface area is the base. I'm not quite sure why all of the books put a capital B here. I don't really like that, but as long as you know that B sub A means the area of the base plus the lateral area, right?
So this is just of a...
They want just the lateral area. So we need the formula for the lateral area.
This is a square pyramid, though, isn't it?
Yes. Well, it's not necessarily a square. It could be a rectangular pyramid.
Well, for the formula purpose, it's the same thing, right?
Yeah, I think it is, yeah.
Okay, you said the formula yesterday was for a square pyramid, the area of a base plus half lambda times the perimeter?
Yes, perfect. Remember that the lateral area of a cone is pi RL.
Well, now I'm confused. You're saying
No. Lateral area of a cone. I'm bringing this up just to distinguish it from a pyramid.
Right, it's not that I'm confused on.
Okay?
You said, like, square pyramid is the area of base plus half lambda times pi. But what you're saying...
Not pi, that's perimeter.
Perimeter, sorry.
Okay.
But you're saying surface area for squared pyramid is the area of the base plus the lateral area?
Yeah. That's the same thing I said yesterday. I said it was the area of the base plus 1/2 LP. In other words, lateral area, this is lateral area here. So if you substitute 1/2 LP in for up here, it's the same thing I said yesterday. The only reason I wrote it differently is because they don't want the surface area. They want just the lateral area. So we only need to pay attention to that. You with me?
Yeah, I'm just writing this down because I'm going to get mixed up here.
Okay, I guess we have to assume that this is a square, even though it looks like it isn't, because we wouldn't really have any way to figure out the perimeter if it wasn't a square.
Okay.
Notice that if they made this a rectangle, we couldn't distinguish it. They wouldn't give us any dimension here, so we have to assume that that's 43. What we don't have yet is lambda. We can figure out the perimeter. It's going to be 4 times 43. So the lateral surface area is 1/2 lambda times 4 times 43.
Where are you getting 4 from?
There's 4 sides to this square.
Oh, okay.
P is perimeter.
Right.
Okay. So what we have to solve for is lambda. They didn't give it to us.
Okay.
What they did give us is this vertical that comes from the vertex to the center of this square, even though they didn't draw it like that either. But we have to assume that it is. Notice that lambda is going to be, can you see the face I'm pointing at here?
Yeah.
If we draw a vertical down that face, kind of like an apothem, that's lambda. So how do we figure out what that is? Well, if we look at this head on, if we look at this from the face that says 43 on it, if this is a crystal and we're staring at it, we're going to see this triangle with the 25 yards is this dimension here. Right? You with me?
Yep.
What's the bottom length?
43.
No. Remember, this vertical goes to the center of that square.
Okay.
So this has to be half of
Oh,
43.
half of 43.
21.5. Now solve that triangle for the hypotenuse, and that hypotenuse will be lambda. This is lambda.
All right.
So what is it?
That comes to 32.97.
Okay, so we've replaced that with 32.97. Then we have 1/2 times that. That's about 16. No, that's more like 16.5. Times 4 makes it 64 times 43. Well, what's 65 times 43?
I don't know.
You have your calculator?
Yeah.
65 times. The reason I use 65 is because I rounded this off, and I rounded it pretty low, so let's jack it up one.
27.95.
Notice that there's only one answer in that neighborhood, so I didn't have to use a calculator. Well, I guess I did. I had to figure out 64 times 43. So it must be B.
Okay, so just to be clear here, the surface area of a square pyramid is the area of the base. And
Sure, there's a base.
Area, you have to do half lambda times the perimeter.
Yes, the perimeter of the base.
Okay, but if it just asks you to find the surface area of a square pyramid, all you have to do is the area of the base.
No, look at my formula here. The surface area is the area of the base plus the lateral area.
Okay, this is different from what you said yesterday.
No, it isn't, Ryan. What I said yesterday, you just read it back to me. I said the surface area equals the area of the base plus the lateral area, and the lateral area equals 1/2 lambda p. So that's what I said yesterday, which is exactly the same thing that I'm saying today. It's just maybe I put area of the base instead of B sub A. B sub A means the area of the base.
Okay.
Okay? I mean, the way to think about surface area is you have to count every face. So you don't really need to memorize that formula. Look at that picture. Well, we've got a base, plus it's the area of the 4 triangles. Well, it turns out if you go to calculate the area of those 4 triangles, you're going to have, remember the height of each triangle is lambda. So it's 1 base, 1/2 the base times height on each of the 4 triangles. That comes out to be lambda times p. If I were to figure out the area of each of these triangles, the height of each one is lambda.
All right.
It's not 25. In other words, if you measure the height of that triangle, if I draw that triangle out and measure the height, it's bigger than 25. It's the hypotenuse of that triangle we were looking at.
All right.
Okay. Okay, now we get to the surface area of a cone, which is similar. It's the area of the base, but n plus the lateral area. So it starts off the same. It's just that the lateral area is different. What's the lateral area on the cone?
Isn't the surface area of a cone pi r squared plus pi rl?
Yes, the lateral area is pi rl, and the area of the base is pi r squared. This problem only asks for the lateral area. So if you only had this memorized, you might not, or let me say this. Let's say you wrote this down as this. and you didn't memorize this part. So
Okay,
you memorized this.
The way I wrote it down is I have it in different kind of charts. Like I have the area, surface area of a cone, and then the volume, and that's it. So the
That's
rate.
right. So if I ask you what's the lateral area, you're not going to be able to give it to me. You need to know what the lateral area is.
Okay, how do you find the lateral area of a cone?
Well, that's what I was writing. The lateral area is what pi RL is. So when I write the surface area, what I'd really rather write is it's the area of the base plus the lateral area, and then memorize a second formula that the lateral area is pi RL. Because you really need all three. You need to know what the surface area is, you need to know what the volume is, and you need to know what the lateral area is. We're looking at two questions, the last two questions that only asked for the lateral area. They did not ask for the surface area. So if you did not know the formula for the lateral area, you wouldn't have been able to do these.
All right.
Now, for a cone, there are circles involved in a cone. So we know pi is in the answer. So it's pretty easy to remember cone goes with pi RL. A regular pyramid, like 35, did not have any circles anywhere. So we would not expect to find pi in the answer. And it's not. It's 1/2 lambda times the perimeter. Okay. So what's the lateral area of this cone?
30 pi L. So then you turn that into...
What's L?
L is the hypotenuse, so it's
Okay.
The square root of 40 squared plus 30 squared.
Look at that triangle. That's a 40, that's a 30. What's the hypotenuse?
50.
Okay. It's better to recognize a 3, 4, 5 triangle than to go through the math of having to figure it out. So 50 is L. So 1500 pi is the lateral area. Where did we go wrong? It has to be a misprint. Oh, no it isn't. What did I do wrong? What's 1500 pi equal to? Notice there's no pi's in any of the answers.
Okay, 1500 pi is 4712.
Yeah. So that's the answer. And notice that the 40 meters that they gave you is not involved in figuring out that, well, I guess it was, because we needed that 40 to figure lambda. So it was involved, yeah, sorry. Notice what happened there. It took me 30 seconds to figure out what the heck was going on. I came up with 1500 pi. I looked up there. I didn't see any 1500 answers. And I immediately started thinking I'd made a mistake or they had made a typo or something. It took me 30 seconds to realize that none of their answers had pi in it. In other words, I had to turn this pi into a number and come up with, well, what it was.
Right.
Okay, the volume of all prisms is what?
Of all prisms?
Yeah, every prism that you want to talk about has the same thing for the volume.
We did not do that. So what is it?
Let's talk about a cylindrical prism. Notice that why this is a prism. It's got two bases that are the same circle, opposite, parallel. What's the volume of that prism?
Of a cylinder?
Yeah.
Pi r squared times the height.
Notice that that's the area of one base that makes up the prism times the distance between bases, which is the height. So that is the general formula for the volume of any prism. It's the area of one base times the distance between the bases. That's the general volume. Huh?
It's the same as a cylinder, though?
That's what a cylinder is. That's what a rectangular brick is. If I gave you a brick and said, what's the volume of this brick? I would take the area of the base and I would multiply it by the height of the brick. Same thing with the cylinder.
Right. The cylinder, though, I guess it was a dumb question. Never mind.
Okay, look at this figure here. What constitutes the two equal and opposite bases?
What's that?
What makes up why is this a prism?
Because it has two parallel sides.
Which ones are they?
The parallel sides?
Uh-huh. Which faces of this prism make up the bases?
The back one that has 1 on it, and then the one next
Is
adjacent
it a triangle? Is it a triangle or a rectangle?
rectangle.
No. There are no two rectangles here that are parallel to one another. There's 3 rectangles. There's the one in the back, there's this one on the right, and there's this one on the left. But none of them are parallel to one another. So what two faces of this object are parallel to one another?
The triangles, then?
Yes. So to find the volume of this thing, give me the area of one triangle times the distance between the two triangles.
Well, it'd be, the area would be base times the height. So
No, it's 1/2 base times height, because it's
right.
a
Well, I was saying divided by 2, but...
Okay.
And then,
See,
so...
I'm a firm believer that the way you memorize things and say things are important. I never, ever, ever say a triangle area is base times height divided by 2. To me, that's not the way to memorize it. It doesn't matter as long as you do the same. If that's what you always do, then that's what you should do. But what I always do is it's 1/2 base times height. I don't say base times height divided by 2. I don't know why. It's easier to memorize. If I use both expressions, it makes it harder to memorize stuff. It's just like I always say pi RL. I never say pi LR. It would confuse my memorization ability. Okay. So what's the area of the triangle?
It'd be 1.
What's the distance between the two triangles?
17.
A is your answer. Notice that cones and square pyramids are not prisms. A cone is not a prism. There are no two faces on that cone that are parallel and opposite, nor a prism. That's why we need special formulas for the volume of those, because they're not prisms. All right, So 38. Finding volumes of composite space figures. Just for volumes, it's quite easy. Separate them into two pieces and figure out the volume of each and add them together. Notice that surface area would not be that easy. You see the problems with surface area? In doing that, there's part of the surface area here that is not exposed. The part on the other side, the lower half of it. And there's part of this rectangular brick here that's not exposed. The part that connects to this part. So surface area would be a much tougher problem. Volume is a piece.
What's the formula for the surface area of a regular
There's no formula. For a rectangular brick, I mean, there is a formula, but just count up all the faces. In other words, if I have a brick, you basically have 3 different faces, and there's 2 of each. There's 6 sides on that brick. So you have face number 1 plus its backside. You have face number 2 plus its opposite side, and you have face number 3. So you don't really want a formula for this. A formula would just confuse you. It's unnecessary to memorize the formula.
So you're saying multiply each side?
Each dimension. So let's make this piece right here this brick. So this will be 8, this will be 3, and the depth is what?
The depth?
Yeah, what's this third dimension? Remember that in every rectangular brick you've got 3 dimensions. You got the width, the height, and the length, or the depth, whatever you want to call it. What is it? Yeah, it is 5, because it's 5 for this, and we're to presume that it's the same for both of these figures. So, to get the surface area, every face is the product of 2 of these dimensions, right?
Repeat that.
Every face, face number 1 is the product of 3 and 8.
Okay.
The area of face number 1. Face number 2 is the product of 3 times 5. Face number 3 is the product of 8 times 5. So, if you want to memorize a shortcut to figuring the surface area for a brick, list your 3 dimensions, 3, 5, and 8, and take all combinations of them. And there's 2 for each one. So I can say it's 2 times 3 times 5 without even plus 2 times 5 times 8 plus 2 times, what's the missing one? 3 and 8. 3 and 8. There's always going to be 3 ways to put 2 of these numbers, multiply them together. I multiplied each one by 2 because face number 1 has 2 sides.
Right.
And I don't even care if this is face number 1 or if this is face number 1. I know that the surface area is going to be the product. You give me the 3 dimensions and I'll tell you the surface area without drawing a picture of it.
Okay.
You know what I'm saying?
Yeah.
Okay, let's test you. Here's my 3 dimensions of a random brick. What is the surface area of that brick?
We got, I don't know what my calculator did. We got 4 times 7, 2, 4 times 7 closed, plus 2, 7 times 8, plus 2, 4 times 8.
See?
32.
So you got it right without drawing a picture or without even having to picture which face you were talking about. So here's the formula you really are looking for the surface area of a rectangular brick. It's just difficult to write as a general formula. I guess I could say, and the reason it is because we have different expressions for depth and width. In other words, width doesn't always mean what one person thinks it means. I call it width, height, and depth. Somebody else might call it width, height, and length. So for me to write the formula, I guess I could say it's 2 times width times length plus 2 times width times depth plus 2 times length times depth. So there's the general formula.
Okay.
Okay? So in this problem, let's look at the figure on the left. Oh, we're not talking surface area anyway. We're talking volume here. Volume of a rectangular brick is really easy. It's the 3 dimensions multiplied together. So what's the volume of the one? In other words, volume is length times width times depth. Or rather, height. It's the 3 dimensions, whatever you want to call them. So what's the volume of that?
3 times 8 times 5.
What's the volume of this?
2 times 5 times 6.
And notice that it doesn't matter that they're joined together. If this was a vessel and I wanted to fill it with water, the amount of water that would fill in that and fit in that is the same whether they're stuck together or not. Surface area, it makes a huge difference, but for volume it makes no difference at all. So this is 15 times 8, 120, and this is 10 times 6, 60, 120 plus 60 is 180.
Okay.
Okay?
So the formula you just gave me, that when you get the 3 numbers like 3, 8, and 5.
That was for surface area. That was for surface area.
Okay. And
Which
volume,
they did? Yeah.
and
Now,
volume,
be careful. That's of a singular brick.
right, I understand.
Okay?
That.
It's not of a brick joined to another brick like this. Because
Right.
part of this surface area is covered up.
Right, I understand that.
Okay.
But the volume, how would I write that? Volume of all prisms?
No, the volume of a rectangular brick.
Okay.
Both of these are rectangular bricks, meaning they're made up of nothing but rectangles. Everything's at 90 degrees to one another. Your dimensions of your brick can be anything you want, but a brick is a brick. I mean, sometimes you have a big brick, sometimes you have a fatter brick, a skinnier brick, but it's, you know what I'm saying.
Right. And so the brick is base times height times width?
Right. That's the volume.
Okay.
Let's find the volume of the cylinder.
Alright, that's pi r squared times the height.
Okay.
Leave terms in pi, so is that 25 or 2.5?
2.5, which means 6.25 after you square it.
Okay, 6.25 squared. Oh,
No.
no, I'm sorry, pi times the height. The height is 12.
Okay. So look at those answers and see if you can estimate which one it is. Without your calculator,
My guess would be A. So it's pretty close.
very good. See, I looked at this problem and I looked at one answer, 60. And I said to myself, they've done it again. They've taken pi out. We're going to have to multiply this all out. So I was trying to estimate what 75 times pi was, and then when you gave me that A, I realized that all the other answers do have pi in them, and that is 75 pi for sure.
Excuse me.
Bless you. Okay, volume of a square pyramid.
I need this formula as well. Oh no, I don't. Never mind. I got
I
that.
don't think you do. Why do I know you don't need it? It's because that's the same as the volume of a brick, only it's only 1/3 of it.
Right.
So what are the three dimensions?
Three dimensions are 12, 10, and 12.
So it's those three dimensions, which would be what it would be if it was a full brick, times 1/3.
Okay. And it's the same as 1/3 area of the base times height?
Yes.
Okay.
Notice the area of the base is two of the dimensions times one another.
Alright.
Times the height is the third dimension. I mean, I'm not sure what helps you memorize these, but that kind of logic is what helps me memorize it. I'm never going to forget that because I know what the area of that brick would be. It's 12 times 12 times 10. And I know that because it comes to a point, it's only 1/3 of that volume. I didn't mean the area of the brick, I meant the volume of the brick. Oh, that answer, by the way, is 4 times 120, that's 480. And I said 4 because I divided by 3 first. Okay. So 41. Find the volume of the cone shown as a decimal. Ooh. This is not a right cone. Or this is not a right, yeah, it's not a right cone. Question is, does it matter? I'm thinking it doesn't.
Okay.
In the same way, here's why I don't think it does. I draw a rectangle, and I make a triangle like this. In other words, a perfectly isosceles triangle. I know this is 1/2 the area of that rectangle, right?
Right.
But I also know that no matter where I put this vertex, I can put it there. That triangle is still 1/2 that rectangle. I can put it here. That triangle is still 1/2 that rectangle. So I'm thinking this cone is still 1/3 of the cylinder's volume that it would be even if this peak was where it would be at a right cone, a perfect cone. See what I'm saying?
Yeah. Kinda.
Well, by the same logic that all of the areas of these triangles are the same, even if I move the vertex, I'm thinking the volume of this cone is the same as it would be if this vertex was right in the middle. In other words, if it would be a typical cone problem. Let's figure it out and see if that answer is on there. So if it's a typical cone problem, what's the volume of a cone?
The volume of a cone is 1/3 pi r squared times the height.
I like that. And what's pi r squared?
R squared is 81 pi times that height, so 81 times 22.
Divided by 3 is times pi is what?
94 pi, 1 minute.
1866.1. It's got to be.
All right.
Is that what you got?
Yeah.
Okay. Now, why am I so sure that that's it? Because I wasn't positive that the formula for this cone was, or the volume of this cone was the same as the volume of a right cone.
I'm not sure.
Look at our answers. If I'm wrong, I can't be wrong by very much. In other words, the volume of this cone is going to be awfully close to the volume of the cone that would exist if it had its vertex right here, right?
I see. Yeah.
Okay, well, look at our answers. They got nothing even close to 1866. So if we got 1866 doing it this exact way, then that's got to be right. It certainly is not going to be almost double.
Okay.
Okay? In other words, that is a valid way to solve for the volume of this cone, is to treat it like a perfect cone with the vertex in the middle. All right. We've only got 10 minutes. Your test is tomorrow, right?
Yeah.
Is there any problems you want to go over that aren't in order here? I mean, have you gone through these and seen which ones are liable to give you trouble?
I've gone through it. Let me do that real quick.
Because we may want to skip around here for the last few minutes.
Yeah. My thing's loading 1 minute.
Do you know how to do 42? Let's just go through each one of them and you tell me whether you think you know how to do it or not. And if you do, we'll go to the next one. That's the way to do it.
Find the no, I don't.
Okay. If I told you the similarity ratio between two squares was 3 to 1, excuse me, between the side of two squares, in other words, I have a square here, and I have a bigger square over here, and their side ratio, this is 3 and this is 1. So their similarity ratio is 3 to 1.
Okay.
What's the similarity, or what's the area ratio?
Of a square? 9
No.
to...
Yes, it's 9 to 1. Well, how do we get that? It's the similarity ratio squared.
Okay.
Now what's the ratio of the volumes of these? If I turned them into cubes, how much more volume would the one on the right be that has a similarity ratio of 3 to 1? What's the volume ratio going to be?
3 to 1 cubed.
It's 27 to 1. So if I start out a problem giving you the volume ratio, what do you have to do to bring it down to the similarity ratio? That's what this problem does. They give us the two volumes.
Square root them both?
No. Remember, cube root them both. Cube root them. So we have 1728 divided by 343. We want the cube root of both of these. Well, I recognize this one. Isn't that 7? 343 is 7 cubed. So 7 is its cube root. What's the cube root of 17? It's 12?
Yeah. So you cube root it and then you turn that answer into a fraction.
Because it says ratio.
Right.
Ratios always mean fractions.
Well, the reason I say fraction is because you can do that through the calculator.
Oh, you can, in other words, you divide that first and then take the cube root of it?
Well, I do the cube root of 1728 over 343. it gives you the answer of 1.714, and then you do your answer, that hit math, and then bracket.
Notice the problem of that. That 1.714 doesn't immediately tell you which of these answers is correct.
Okay.
In other words, the better way to do the problem is to take the cube root of 1728 and get 12, and then take the cube root of 343 and get 7. That is one of the answers.
Right. It gives you the answer the same way.
Okay.
It
All right.
does it through the calculator.
Okay. Whatever. That's fine. As long as you know to take if you're given the volumes, you have to take the cube root of each, put them in a ratio, and that's the similarity ratio. Remember, the similarity ratio is always a linear measurement.
Okay.
It's not the area ratio, it's not the volume ratio. The similarity ratio is the linear ratio. I used to call it the linear scale factor. I like linear scale factor better, actually. Similarity ratio doesn't really tell you whether they're talking about area, volume, or length.
Okay.
All right.
So here's one thing we did miss: the surface area of a sphere.
Okay.
And the volume of a sphere.
What's the volume of a sphere?
I don't know.
It's 4/3. That's the only formula I know that has a 4/3 in it. Times pi r, what's this going to be? What's the exponent on the r going to be? Volume.
Cubed?
Has to be, because we have to end up with cubic something.
So 4/3 pi r squared, or cubed?
4/3 pi r cubed is the volume of a sphere.
Okay.
Okay.
And the surface area.
Surface area is 4 pi r, what's this exponent going to be?
Squared?
Because surface area is a square measurement. It's a measurement of area. In other words, the units are going to be meters squared. They're not going to be meters cubed. They're not going to be meters. They're going to be square something, either feet or meters.
Okay.
Okay?
So with the sphere of the radius of 30 meters, 30 meters squared comes to 900 times 4 comes to 3,600 pi.
Okay. Let's see.
All right.
About 44. You know, I mean, we just went through the volume formula. You probably can plug in that. Let's go on.
Let's do 45 and 46.
Okay, 45.
Actually, we're almost out of time. We're almost out of time, so let's do 46.
Okay. 46 is a really hard problem. It's going to take a long time to explain it, and I'm going to have to draw it.
Okay.
45 is probably a lot easier. The reason 46 is so hard is because you have to make a rectangle here. Then you have to deal with the rectangle and this little triangle. And you have to make sure your rectangle sides are parallel, which isn't easy. 46 is a really tough problem.
Okay.
So let's spend our last few minutes more wisely on 45 and maybe another one. But what is angle O? 45 isn't so easy either, but we can do it quicker than we can do 46.
Angle O is 111.
Oh, it's 111. They give you that one, yeah. So if this is 111, what is angle X? What do I know about a circle that has two tangent lines intersecting like this? What do I know about this angle right there?
That's half of what the bigger angle is.
It's half of the difference in the two intercepted arcs. This being one arc, this being the larger arc, this being the smaller arc. So this angle, x, is equal, and this is a formula you're going to need, 1/2 the difference in the big arc minus the small arc that is intercepted by those things. Well, what's the small arc? If this angle is 111, what's that small arc from here to there?
Hold on, I'm writing down the formula real quick. Alright, from where to where?
Well, these two tangent lines cut out two arcs. We need the measurements of both of them. The only thing we have is the measurement of this angle O. What does that tell us about the smaller arc? What is it?
The smaller, would it be 111 and the big arc being 249?
Well, since the small arc is 111, the big arc is everything else in the circle. So yeah, it would have to be 249. Now plug in both of those into the formula and you can solve for x.
So 249 minus 111 divided by 2, so 69.
Yep. And that's how you do that problem.
Okay.
You have to apply two different geometry principles. The number one geometry principle is that if you have a 111 degree angle there, this arc is 111 degrees.
Okay.
Number two is, you know, it has to add to 360, and then you need this formula also. All right, let's stop there.
All right.
If time is a problem when you take this test, I don't know if you have enough time to finish it or you run out of time. If you're going to run out of time and you know it, do not attempt this problem even, 46.
Okay.
Okay?
All right.
In other words, if you have to table difficult problems, when you run into one of these chain gear problems like this,
all right,
that's the one you want to table. Go on immediately to the next problem. Unless you're gonna, if you have time to do all problems, then obviously work on it. But if
we have 90 minutes to answer 70 questions, and they're all multiple choice, so.
Well, if I were you, what I would do is first time through the test, put a little check mark by this and go on. And then if you find you have time and you've done all the other problems, come back and work on that one. But if you don't have time, in other words, if you're not going to finish 70 problems anyway, then make this one of the ones you don't do.
Okay.
Don't waste part of your precious time on this problem. Same way basically you take any test. When you take the ACT and the SAT, you take it the same way. Go through, make sure you do all the easy problems that you can do. If you have time left over, go back and do the tough problems.
Okay.
Okay? All right, well, Ryan, good luck on your test. And have a nice summer. And perhaps we'll work again next fall. When you're
definitely. I'll send you a text on how I do and
okay.
What's going to become of this. I'm pretty sure I'll pass, but like I said, it's very difficult for me. So.
Okay. Well, I hope just get your mind in a good, relaxed space and try to go in there and take the test in that place. You don't want to be in an anxious mood when you're taking the test.
Right.
I think. I mean, as far as I'm concerned, that's the formula for test taking. Is try to know your material as good as you possibly can and try to be relaxed and focused and alert when you go in and take the test.
All right.
Okay? All right, Ryan.
All righty. Well, thank you.
You're welcome. Bye-bye.